Alright guys, welcome back. We're going to be solving another question from the third chapter of Mechanics of Materials by Beer and Johnson. And we have question 11 from chapter 3, and we know that each of the shaft A, B, B, C, and CD consists of a solid circular rod, and we need to determine in the A part of the question the shaft in which the maximum shearing stress occurs. So we have three different shafts, A, B, B, C, C, D, and we need to determine which one has the maximum shearing stress, and in the B part we just have to report the magnitude of that stress. So we solved the question in the previous video very similar to this, and basically we do cuts in order to find the torque that we have in each shaft. Let's start with that, and we're gonna start with the shaft AB. And as we talked about in the previous video, we're just gonna do our cut right before the end of the shaft, and that way we can figure out the internal torque in that member, and we are in equilibrium. So if you have 48 Newton meter torque in this direction, there has to be something in the opposite direction, same value, just to cancel that one out. So the member AB, let's start with AB. For finding the maximum shearing stress, we have the elastic torsion formula. So the maximum shearing stress is equal to torque times the radius of the shaft. We can show it with rho RC whatever over the moment of inertia. Since we are dealing with solid disk, this is going to be 1/2 of pi times the radius. We can show it with rho to the power of 4. So if we just put that in here, this formula can be simplified to 2t. We can cancel out the rho because we have 1/2 of pi rho 4. So the 2 goes to the numerator, so 2t over pi radius to the power of 3. So let's just figure out the first one. 2, as we talked about, the torque in here is 48 Newton meter over pi, and the radius, we have the information, it's 15 millimeter. So that's going to be the diameter, and we need to divide that by 2. So 7.5 millimeter, we're going to do 10 to the minus 3 in order to get the unit consistent. We have Newton meter in the numerator, so all to the power of 3, and that's going to give us the first shearing stress. Let's see what we get. So 2 times 48 over pi times 7.5 divided by 1,000, all plus 1, all to the power of 3. So that's going to give us 72.4 times 10 to the 6 Pascal, or we can just report it as 72.4 megapascal. So that's for the member AB. Let's move on to the member BC. Same idea. Now we have a different cut. I'm just going to clean up the previous one. So maybe shoot this one with red. So we're going to do our cut right before the point C. And one thing I forgot to mention, so you can consider either the left side of the cut or the right side. But the problem with the right side is that we have some reactions at this support, which we don't know. So it makes sense to go with the left side because we have all the torques as a given. So it's easier for us to figure it out. So we have 144 in this direction and 48 in the opposite direction. So it's going to be 144 minus 48. And in order to cancel that one out, we're going to consider this. So that's the internal torque that this member is experiencing. So same formula. I'm just going to put different torque in here, which was 144 minus 48 over pi. Looks like the diameter is different too, so keep in mind we need to divide this by 2 because it's a diameter. So 9 divided by 1,000, I'm just going to put it 0.009 all to the power of 3. Let's see what we get here. So I'm just going to put 9 in here, and also we have different torque. All right, that's going to give us 83.8 megapascal. Looks like the member AB is not an answer because this is higher, and we need one more member to check, and that would be the member CD. So again, same idea, we have to do our cut. Let's just clean up the figure. This time we are interested in member CD, so we do our cut right before that support, which means basically we have all these torques, and it's going to be in this direction. So 144 plus 60. We have to consider the direction. So these two are in the same direction, and we have one clockwise if we look at it from this side. One clockwise, so negative 48. So very similar, we just have different torque in here. So 2 times 144 plus 60, negative 48 pi. And I think we have different diameter too. Yeah, so our diameter is 21 millimeters. So 21 divided by 2, which is going to be 10.5 times 10 to the minus 3, all to the power of 3. Let's see what we get for this one. So I'm just going to add 16 here. And here we're going to have 10.5. And this is going to give us 85.8 megapascal. And this is going to be our winner for this question. 85 is bigger than 83 and 72. So the answer for this would be the member CD. And that was the A part, and the B part we have to report the magnitude, which is basically what we found in here, 85.8 megapascal. And yeah, so that's everything for this one. Hope everything was clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.